In this video, I'll walk very quickly through a series of practice problems to get us ready for discounted cash flow. And I'll begin with the mini quiz that we used on Monday, where you were given a scenario where you might purchase a firm, bring it out of some negative cash flows into some positive cash flows, and then sell the firm for a nice hefty sales price. And the question was, what would be the value we create? Well, that's just the net present value of the total cash flows. And if we were able to fund it ourselves with the 200 million, what would be the rate of return of those same cash flows, which include that 200 million investment? And so as we know, we can't just take the NPV function and point it at this. We have to take the first cash flow because we don't want it discounted, and then use the net present value function, which is probably misnamed in Excel. Long story. And then take the remaining cash flows, the first of which even will be discounted for one period. Of course, the second will be discounted for 2 periods and so on. And what we find is that if we could actually pull this off, we'd create about $21 million in wealth, a nice return for our team. And in fact, if we could fund it ourselves, that 200 million would enjoy a 22% rate of return. So we see that on the solution. In the next problem, it's very similar. We have a firm throwing off some free cash flow that we'll sell in the future, but here we're not purchasing it at any time. We already own the firm. And so we would like to know what it's worth at the end of 2019. We're assuming that all of these cash flows occur at the end of the year, which hopefully is in the problem somewhere. Yes, and so we want to know what's the net present value of these cash flows. This probably feels like a trick problem because every time up until now we've added the first cash flow. But think about it this way. These cash flows occur at the end of the year, and the first year is 2020. We want to know the present value at the end of 2019. So we actually do want it to discount the first cash flow. And so we simply use the NPV to find out the value. Take some time to read these study notes on the solution. I won't read them to you on the video. In the next problem, we're going to do exactly the same math, but we're going to get used to doing this in a horizontal fashion instead of a vertical fashion, which explains the name of the previous problem. We just take the NPV using the discount rate and the future cash flows. And notice the form of this problem. We've got a sales price of the firm that's being added to that cash flow in the last year, just like it was in the previous problem, 2 problems in fact. But this is a very important concept to notice. And make sure we match the solution. Take some time to read those study notes. I won't read them to you on the video. This time it's once again the same exact problem with the same exact math. But I put these blue numbers in here. These are historical numbers. And so when we look at the solution, there are some study notes out here that say in the pro forma models, we generally see those historical numbers. It's kind of nice for reference to say, hey, does our forecast sort of line up with the same trend we were seeing in history? And hopefully it does, or if it doesn't, hopefully there are reasons why not. But we don't want to include those in our calculations. We'll follow this formatting scheme of putting historical numbers in as blue, and so almost always, if not always, we can ignore those blue numbers. Don't come down here and try to calculate a present value at the end of 2019 that depends on something that happened in 2017 or 2018 or even earlier in the year in 2019. So just look at the point forward just like we did in the previous problem without that data, same exact math. Now let's think about what might happen if we didn't sell the firm, if we wanted to just go forward and keep that firm. So I think in this problem, we're saying instead of selling it, we're just going to assume that we keep it in the family and that the long-term growth rate, which begins in 2025, is 3%. So we just take the previous year times 1 plus the long-term growth rate. And we see in the next year it's up to 248. If I copy and paste, it's up to 256. And I could do that for 200 years. I don't want to try to find that 200th cell. So while I've got it copied on my clipboard, I'm going to just come up a row. I call this the fast lane trick, and do a control right and then come back down. So I took the fast lane. Now I'm going to do a control shift left and paste with control V. And you see that after 200 years, this firm is making almost $90,000 a year and still going up quickly. Sounds like a ridiculous amount, but if we take the NPV of that, using the same logic that we did the last couple of times, then at the end of 2024, all those future cash flows happen to be worth about $5 million rather. We could use the Gordon formula and say instead of 200 years, what if it went forever? And that's pretty easy math. We just need the 2025 cash flow, which we don't really want to calculate it here if we're not calculating all these. I'm just going to use the 2024 cash flow and grow it by 1 year, which is exactly the same thing we did to get K14 over there. And then divide it by the discount rate minus the growth rate. And we are almost exactly the same number there. The only reason this terminal value using the Gordon formula is a little bit higher than 200 years of cash flow is because it has the rest of eternity to produce cash. And the rest of eternity only makes about 400. Not very much, so 200 years captured the vast majority of that. But even though this is more accurate, which is great, more importantly, it's a whole lot easier to do this than it was to do all of this. And so going forward, when we want to assume a terminal value based on a long-term growth rate, this is how we're going to do it. We're going to refer it to the terminal, the cash flow in the terminal year, and we're going to place this value in the terminal year so that we can add it to that terminal year cash flow and discount it back to whatever we're looking for, just like we did if we were selling the firm. So the analog is to selling the firm. There may even be some comments about that down here. So let's go ahead and try it. We will use our terminal value formula again, which is the terminal cash flow times 1 plus the growth rate in C9 divided by the discount rate in C8 minus the growth rate in C9. And we see our terminal value that we expected. So let's add that to the cash flow. We can go ahead and copy and paste that formula. I like consistent formulas. It doesn't matter if we're adding a blank cell in there or not, but the implication is that the sum, so let's go ahead and do it. And then we'll take the NPV at the discount rate of these cash flows. A couple of study comments here that would be worth looking at. Let's move on and think about what would we do if these cash flows didn't occur at the end of the year. We are getting some great practice here by coming in and calculating this terminal value over and over, which will be great practice, I promise. Sum it up, copy it, and take the net present value. Now we're still assuming that these cash flows are occurring at the end of the year. So there are two ways we could fix that. One is just take our answer and multiply it by 1/2 a period of growth, or excuse me, of discounting. Which makes it a little bigger. Let's think intuitively, does that make sense? And it does, because if each of these cash flows occurred 6 months earlier, then the present value should be larger than if they occurred at the end of the year. And they are, in fact, larger by 1/2 year discount. Let's look at the solution and see another way to do this. We could have gone in and inflated each of these, moved it forward in time 6 months, made it that much bigger using that same adjustment that we did. And then when we took the net present value of these, they're larger, and Excel is treating them as if they're at the end of the year and giving us the larger NPV that way. So the 4343.6 is the correct answer here. So this might be something you could expect on the quiz, where I give you a word problem that tells you that we have forecast explicitly some cash flows for the next 4 years. And after that, we want to assume that cash flows grow forever at a certain rate, and assume that all the cash flows are occurring in the middle of each period. So as we saw on the last problem, we can go ahead and calculate the NPV and then adjust it. So we want to compute the present value of the cash flows at the end of 2019. So I'm going to have a date over here, probably 2019, 2020, and so on. So I can put those values of 200, 220, and so on. Which represent my explicit forecasts. Later in the course, we're going to work really hard to get to these cash flows. Today, I'm just giving them to you. And then after that, we'll just estimate a terminal value using one of two methods. Today, our terminal value is using this Gordon model of constant growth, because we need our growth in there, don't we? Since both of those are inputs, I'll go ahead and color them that way. And I know that I'm going to want the, from my total cash flows, I'll calculate the present value at the end of 2019. Make a box for that. So the terminal value is the last cash flow times, actually grow it by the growth rate to get it to be the next cash flow, divide it by the discount rate minus the growth rate. Sum up all those cash flows we're getting in the last year. I like to just copy that formula over and then take the net present value. Now if we stopped here, we'd have the net present value at the end of 2019, which is the label I put, based on cash flows occurring at the end of the years. But if that 200 really occurs at the middle of 2020 instead of at the end, then it's going to contribute more to the net present value. So this number has to go up by 1/2 period. So I'm just going to multiply on the end, 1 plus the growth rate, 1 plus the discount rate, to 1/2 a period. And you can see a little bit cleaner version on the solution. As you go through the rest of these quiz samples, we're playing around with basically the same thing. This one says assume that the cash flows occur at the beginning of the period. This one says assume that they occur at the end of the period. I guess we did middle, beginning, and end. This one we're going to flip-flop and say we have dated cash flows, and we assume that they're all occurring at the beginning of each period. And we still have a terminal value growing at 2%, so let me calculate that terminal value. I hope you're doing this a lot because I want you to get a lot of practice at this. XNPV, give it the discount rate, the values, and the beginning dates. I've given you both the beginning and the end to choose from. So hopefully 3716 is the right answer. And now let's try one with dated cash flows occurring in the middle of each period. So our quarters go along and we need to calculate the middle of each quarter. and then later each year. We'll use average to do that. By the way, I can highlight all those cells and hit Control-R to copy that. And then we can go ahead and do our terminal value. And then the XNPV using the dates at the middle of the period will actually give us an NPV at that first date, which is February the 15th. But we have a formula to convert that future value into a present value by dividing by 1 plus the discount rate to the power of the time between these two dates. And the time between these two dates we will take as this date minus this date. We want that as a fraction of a year, so we'll divide by 365. We can even go by a quarter since every fourth year is a leap year. And so the present value at the end of 2019, technically we counted it on January the 1st, is 3572. Similarly, you can do the same thing when these cash flows occur at the end of these periods. You'll need to use this for the dates and then adjust your answer by the difference between these two dates. There's one more problem I would like to look at. Let's go back to the very first problem in this file where we calculated net present value and rate of return of this series of cash flows. And my question for you is, if we deferred that project for 3 years but had exactly the same cash flows, how would that affect the present value and the rate of return? So take a look at that. That's a subject that comes up a lot. A project may have the same rate of return regardless of when you do it, but its net present value may be more to you if you can execute it today than it would be to someone else who can't execute it until the future. And I hope this video was helpful.